So on this one, they're asking us to do both of them on the same graph, right? So let's focus in on this guy first. Now, is there a H or K shift on this one? What is your H value and your K value? Anybody? There is no H, so H is 0. The K is also 0 because there is no K. Does that make sense? There is no number inside the root with the X. You don't have to think opposite. I mean, technically, I guess you could rewrite this thing as y equals 2 the square root of x minus 0 if you wanted to see an H, and a plus K of plus 0 at the very end, right? But the bottom line is there is no H or K. That means that the beginning point is 0, 0, just like the parent graph, okay? We still need some coordinates to graph this thing, so it'll be a good idea to go to an XY table once again. And let's plug in some values. Perfect square numbers are nice. The square root of 0 is 0, and 0 times 2, again, the square root of 0 goes in right here, and 0 times 2 is 0. Like I said, it's the same starting point, the same HK value as the parent graph. If we plug in 1, then we're going to have the square root of 1, which is 1, times 2, which is 2. If I plug in a 4, I'm going to have the square root of 4, which is 2, times 2, which is 4. And how about 9? If I plug in 9, what do I get as an output, guys? 6. Thanks for being awake. So we have those coordinates. Let's graph those coordinates. So if I go, okay, so I've graphed the coordinates that we came up with, 0, 0, 1, 2, 4, 4, 9, 6. As you can see, it's very similar to the parent graph, which is the y equals the square root of x. Now, let me actually zoom in and compare this new one to the parent graph. Let me graph the parent graph right here. So, ladies and gentlemen, this green one is y equals the square root of x. That's the parent graph. And this new one is y equals 2 square root of x. So what's the difference between the original parent graph green one and this new red one? It's the same type of curve, it just got vertically stretched. It's like if somebody took this green line and stretched it, right? So the curve got wider. Does that make sense to everybody? Okay, now why did the curve get wider? Because there's an actual 2 out here. There's a 2 out here, which makes it stretch. Now, if the A value is greater than 1, it will be a vertical stretch. If your A value is less than 1, it's actually going to be a compression. Now, that makes total sense, because if you take any number in the world, let's say 10, and you multiply it by 2, 10 times 2 is 20, it grows, it gets stretched. But if you say 10 times half, that becomes 5, it gets smaller, it gets compressed. So if your A value is greater than 1, it's going to grow. If your A value is less than 1, it's going to shrink. It's going to compress. So right here, the A value is 2. It's greater than 1. It grew. Now, that's true even for the smallest types of numbers that are greater than 1. Like if you say the number 10 times 1.1, well, it's going to become 10.1, right? It's going to grow a little. So as long as your A value is greater than 1, it's going to grow. It's going to stretch. As long as your A value is less than 1, it's going to compress. So if I were to compare it with the other one that they wanted us to graph, the other one was y equals 1/2 square root of x. Guess what would have happened? Or what's going to happen? It's going to compress. It's going to be closer to the x-axis. Here's the parent graph. This one with the A value of 2 got stretched. It got stretched. From this coordinate, it got stretched to this one. From this one, it got stretched to this one. If it's a 1/2, this one's going to actually compress. It's going to shrink. It's going to get closer to the x-axis. So let's again do an XY table. Let me do it in blue here. XY table, if I plug in 0, I'm going to get out a 0. If I plug in a 1, I want to get out a 1/2 because 1 times 1/2 is 1/2. If I plug in a 4, the square root of 4 is 2, but 2 times half is 1. If I plug in a 9, the square root of 9 is 3, but 3 times half is 1.5. So if I graph these coordinates now, let me zoom in and graph them. So there are my coordinates to this y equals 1/2 square root of x. As you could see, The A value causes the original parent graph coordinates to get cut in half. The height of this original one was 1, now it's half. This one was 2, now it's 1. This one was 3, now it's 1.5, which is half of 3. So it does compress it. So your A value stretches or compresses. Let me finish graphing it. So there's the graph of y equals 1/2 square root of x. So we need to understand how A affects our graph. It stretches it, it compresses it. Not only that, if the A is negative, it gets reflected on the x-axis. And let's say you did have, like let's say I told you to graph this guy. Let's say y equals 2 square root of x minus 2 plus 5. Now let's say I told you to graph this guy. How to do that is this easy. You focus in just on your parent graph without the h and k. You ignore h and k. So it's probably a good idea to identify your h and your k. Your h in this case would be positive 2. Your k in this case will be positive 5. So the h being positive 2 means you're going to shift 2 in the positive direction. And k being positive 5 means you're going to shift 5 in the positive direction, up. So what you would do is ignore h and k once you identified them and graph the coordinates of this guy, which we just did. Y equals 2 square root of x, or these coordinates. It's that red line. All you'd have to do now is get your h and your k and shift your red line right here, the y equals 2 square root of x, shift them 2 to the right and 5 up. So all you'd have to do is go to this red line and move this original starting point 2 to the right and 1, 2, 3, 4, 5 up. So this is your new starting point. You would have to take this next one and go 2 to the right and 5 up. And that would be your next coordinate, and so on and so on. So if you do have something that has an A value that's not 1, like this guy right here, the A value is not 1, and you have an H and K, ignore H and K after identifying them, graph this guy, and then shift the coordinates according to your H and K shifts. Does that make sense?
Yep.
By the way, let's identify the domain and range of these guys. And actually, all of these have the same exact domain and range. All domain and range could be identified with your HK values. Okay, so all of these domain and range values would be what? Domain, x is greater than or equal to 0. Range, y is greater than or equal to 0. Why? Because in terms of x, left and right, they all start at 0 and go to the right, greater than or equal to 0. The range, in terms of up and down, they all start at 0 and they go up. Doesn't matter if it's a compressed one or a stretched one, they still go up. Y is greater than or equal to 0. Now, on the other hand, this last one that I just said, let's pretend that it had an H and K shift, right? 2 and 5. Do I really have to graph this whole thing and shift the whole thing to be able to state the domain and range of this guy? No. If I know my H and K, which I do, here's my H, here's my K, now I know how it looks like and I know where it begins, so I should be able to state the domain and range. The domain would be x is greater than or equal to what? 2. And the range should be y is greater than or equal to what? 5. Now, of course, if we wanted to graph it, all we'd have to do is shift this graph right here, shift that graph 2 to the right and 5 up, and we'd have the graph of this whole thing.